Hi all. We were looking at collisions, and this is the second video of collisions, right? So in the first video, we looked at what is called as a perfectly inelastic collision, right? Now in this video, we're looking at what is known as an elastic collision, right? Now for an elastic collision, what is an elastic collision? Is a body M1, right? It has a velocity, initial velocity u. It comes and strikes a body M2, and then they both start moving at their own individual velocities, right? So you have body M1, it strikes, and then body M1 starts moving with a velocity, I'm going to put it as V1, and body M2 starts moving with a velocity V2. And we're saying this is a perfectly elastic collision, or it's an elastic collision. Now straight away, now what we need to figure out is what is V1 and what is V2, okay? These are our two unknowns. We apply the first great law of conservation, which is the law of conservation of momentum, and from that we can straight away say m1 initial velocity, that's m1u is equal to m1 v1 plus m2 v2. Okay. Straight, this is the law of conservation of momentum. Now, there are two unknowns, right? So you saw it in the inelastic collision, you had just one equation and you solved it, but here now there are two unknowns. What is the next equation? This is where in elastic collision we apply the second law of conservation, which is conservation of energy, and specifically the conservation of kinetic energy. We know that in elastic collision, the kinetic energy is conserved. So if I were to write the equation, you get 1 by 2 m1 u squared is equal to the kinetic energy before the collision is equal to the kinetic energy after the collision. Okay, so this is v1 squared m1 v1 squared plus 1 by 2 m2 v2 squared. Right. So here we are the two equations. These are the two equations which will come out. And for the first time, we're going to use both these equations, as I said, the great laws, conservation laws together, the conservation of momentum and the conservation of energy. We have two equations from the two laws, two unknowns. We can solve for V1 and V2. Now, I'm not going to go in detail into the derivation and find out the solving of this equation that's given in a textbook. I'm just going to take out the result here. And therefore, when you solve these two equations, you're going to get V1 is equal to M1 M2 by M1 plus M2 into U, and V2 you're going to get is equal to 2 M1 plus M2 into U. So because you've already given M1, M2 and U, you get V1, and V2 you get it in terms of M1, M2 and U. So hence you have solved for V1 and V2. Now I want you to get a feel for this equation, and when you look at these equations, I'm going to take three scenarios, right, and consider what three case scenarios of elastic collision and see what happens. And the three scenarios are like this, right? In the first scenario, we are saying the body M1 is much greater than M2. In the second scenario, we are saying the body M1 is equal to M2. And in the third scenario, you're saying body M1 is much less than M2, or M2 is much greater than M1. So in the first scenario, you can consider M1 is like a billiard ball coming and hitting a table tennis ball, where M1 is much greater than M2. What happens to V1 and V2? We'll see that in the case of V1, M2 is negligible over here. So, M2 is negligible, M1, MM cancel, so you get V1 is equal to U. Right. What does this mean? That the billiard ball, it comes, hits the table tennis ball, and it continues to move with its velocity as though nothing even happened, right? And that's pretty obvious. That sounds obvious to us. What about the second body, that is the table tennis ball? So in the case of the table tennis ball, you'll find the smaller, M2, which is much less. M1 here is much greater, M2 is negligible, so you find this being 2U. That is, it moves with double the initial velocity of the M1. So m2 moves with double the initial velocity, right? So this happens in a scenario like this. What about the second scenario where m1 is equal to m2? When m1 is equal to m2, you're going to see v1 is equal to 0 because m1 minus m2 becomes 0. That is, the first body hits the second body and stops. And maybe you see this happen in a billiard table. You've definitely seen this happen in Newton's cradle, right? Newton's cradle, when we took an equal ball, we left it, it came, hit, stopped, and another ball started, right? So when m1 is equal to m2, this stopped. Now look at the other ball, v2. m1 is equal to m2, so 2m1, 2m cancels, and we get v2 is equal to u2. And this is exactly what you see in a Newton's cradle. The first ball, both have equal masses, one comes, hits the other, the first one stops, the second one moves with the same velocity. That's the result for you. This mathematically, it gives, this is how the Newton's cradle works, right? I look at the third case over here, all right? It may be not clear on board, so I'm going to just write up. The third case is, or the third scenario, let's say, is m1 is much less than m2. Okay. What happens in this case? We find m1 is negligible, and therefore minus m2 cancels, and you get v1 is equal to minus u1, minus u. So you shoot up your table tennis ball, it goes, hits the billiard ball, and what do you expect? Obviously the billiard ball is pretty big. It hits, it's going to come back, right? The minus sign shows that it's going to come back, and it rebounds at the same velocity with which it moved forward, right? What about v2? We find v2 is equal to, you find that m1 is too small, therefore v2 is equal to 0. The second body is a huge body, it does not move, right? And I think that's that again is pretty intuitive, that the smaller body goes and hits, it rebounds, whereas the big body just does not move. And that is mathematically we've shown the physics, mathematically we have shown what is really happening in this case, right? So here are the three cases which gives you to show you what is really happening in an elastic collision. Now we go back to our the idea of caroms, where we are hitting the striker on another coin and the coin moves. Where does that come, right? So such a case, in most cases, in real life, it is somewhere between an perfectly elastic collision and or an elastic collision and a perfectly inelastic collision, right? So therefore, we know that the striker, it goes and strikes, and they both move. And what happens is, it's not a perfectly inelastic collision, and it's not perfectly elastic because some kinetic energy is lost. So the case of the carom board is clearly between that of this first case, which is inelastic collision where both of them stick together, and a perfectly elastic collision where the kinetic energy is conserved, right? So I would also like to end by looking, a generic case for an elastic collision, right? And what I mean by a generic case is a case where you have m1 and you have m2. And in this particular case, m1 is moving with an initial velocity u1, and m2 is moving with an initial velocity u2. Once they strike, then m1 moves with the velocity, final velocity v1, and m2 moves with the final velocity v2. How do you find v1 and v2? Now this again is the case where we bring together the two great laws of conservation. So from the law of conservation of momentum, we have m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2, right? And now we apply the next law, which is the conservation of energy, right? Which is the energy. This looks a little slanted, so I'm going to give it a little m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2, right? And the second law's equation, the kinetic energy before the collision is equal to the kinetic energy after the collision. 1 by 2 m1 u1 squared plus 1 by 2 m2 u2 squared is equal to 1 by 2 m1 v1 squared plus 1 by 2 m2 v2 squared, right? This is equation number 1 and this is equation number 2. And using these two equations, there are two unknowns, two equations, you can solve for v1 and v2, right? So this is a scenario where you use both equations to solve it. And remember, this scenario is elastic collision, where the kinetic energy before the collision and after the collision are conserved, okay?